Okay, my friends, let's do a quick review on how to find the real number roots. So finding solutions that work. Okay, we're going to use both methods, prime factorization or quick square root method. But hopefully you guys are going to catch on to these very quickly. Guys, what's the square root of 121? 11. Okay. Should I have to go any more than that? Now, but at the same time, could you rewritten that as the square root of 11 times 11? And then we would have known 11 would come out. Now let's look at this one. The square root of a negative 49. This would be what? No real what? Solution. Yep, no real number solution. So no real number. So for this case, because how would you rewrite that? We would rewrite that as a negative 7 times what? 7. Well, but that negative messed it up, right? We can't take square root of a negative number. All right, now let's look at the next one. What is going to be the cubic root of 27? Yeah, because if I did the prime factorization of that, 3 times 3 times 3 gives me what? 27. That's going to be 3. Now let's look at the next one. Oh, I got the cubic root of a negative 27. Can I rewrite that like this? Oops, I got to make sure I have my negative there. Hold on. Correct? So, what is the cubic root of a negative 27? So, negative 3. So, we can have a negative in that case. All right, let's see if we got the next one. What's the cubic root of 8? I know this is, sometimes it is nice. What can I say? We get 2. Okay. Cubic root of a negative 8. Negative 2, because again, we can rewrite that as a negative 2 times negative 2 times negative 2. You get a negative 8 3 times, and we get a negative 2. Are you guys with me on that? Okay, now let's take it up a notch. The fourth root of 81. 3. Because how do we get that? This time, I'm looking for, my index indicates, I want to look for, using the prime factorization, groups of what? 4. Something multiplying times itself by 4. And the fourth root of 81 is just what value? 3. Correct? And you could also think of it as like, if you like parentheses better than multiplication, that's great. But still, I have 4 of them, so that's the case. Now, question. Can I rewrite the fourth root of a negative 81? Go negative 3 times a negative 3 times negative 3 times negative 3. No. No matter what, if I multiplied all those together, that's going to give me a positive what? 81. What am I looking for? So what's my answer for this? Yeah, no real solution. So are we starting to see some patterns? If it has an even index, so like the second root, the fourth root, the sixth root, what can't I have underneath my radical? A negative. But if it's an odd, does it matter? I love when you guys already got this in. All right. Yes, question?
Yeah, I was just going to ask, when this shows up on quizzes or tests, do we actually need to put no real solution in the number?
I would. I put no real solution. I put no real solution because you're going to find out there are solutions later. Just not with real numbers. Okay. With complex numbers you use. So it's better to say no real solution. It's just a finite, a little nuancey thing that saves a lot of pain later in life if you understand it now. All right. So after working with some of these examples, when can you have a negative answer when you're working with radicals? When the root, or the word that they're going to use for that is index, is an odd number. It's the only time underneath the radicand that you can have that negative number, and a negative answer is going to come out. Okay, that was just a quick review. All right, now, quick what you were supposed to learn yesterday on quizzes. Are you ready? You're supposed to know how to multiply. Okay? In fact, we use this backwards. Okay? Notice if you are multiplying two numbers, as long as they have the same number root, what do you multiply? The numbers underneath together. but they have to have the same index, the same root in order to do that. So like, quick review here. If I have two values here, what's understood to be out in front with these? 1. So just so we clarify, the numbers out front would multiply together, and the numbers underneath multiply together. So what do we get with that one? Well, what's 3 times 12? Then you take the square root. What's the square root of 36? Okay, now let's just take it up to the notch real quick for what you were doing a little bit yesterday, but we're going to do a quick review on some roots here first. Okay. Quick review. I'm not going to say what. I love this again. Is this overkill, guys? When can we have a negative underneath the square root and still get a real solution? When the index is what? Yeah, okay. I just want to make sure. Is this overkilling a little bit? No, it's not. Are you with me? No, it's not. Okay, I just realized I didn't take attendance. Let me pause this. So let's do a quick review of this and see if we can do it really, really quickly. All right, 3rd degree and 4th degree roots. Guys, remember, I'm looking for values to be able to do this quickly. Now, I do this as a combination package of both using the prime factorization and using the idea of what our indexes work with. Friends, when we do this, prime factorization, negative 16 is that same thing as a negative 2 times a negative 2 times a negative 2 times what? Positive 2, would you guys agree? And then we get here what? X to the 6. Now, here's where I'm going to pull you guys a little bit. I want my exponent to be divisible by what number? 3 this time, right? So notice 6 is already divisible by 3. Now, but 11 is not. But I want to make it as large as possible. So y to the 9th times y squared, does that give it to me? Okay, so now let's see if we look for our pairs. Guys, when we're doing this one, let's see if I can move this out of my way. Here we go. Are you going to move? Here we go. I need to get this thing. It's going to be nasty if I don't get this off. Please move. Here we go. Okay, pop. Okay. So, with this one, my friends, and it's not probably going to like me on this one. Oops. Yep, it's totally... I love when it does this. Can you tell I'm being very sarcastic? It won't let me do it because of the values.
There's an undo button on the blue bar.
I don't think it's going to let me go on there. Do you see how this is the one that they want me to get rid of? I don't want that because it's going to totally, I don't want the text color. Anyway. Anyone got text box? Can I take that off? Nope. Exit drawing. Yes. There we go. The program's changed. It's updated and it's killing me here, Smalls. Okay, anyway, moving on. So we work with it. Guys, what can come out? So we can take out a negative 2 because there's 3 of them. How about this one? What can I do? What comes out that's
X squared.
That's x squared because you just go 6 divided by what?
3.
Because that's x squared times x squared times x squared gives me x to the 6. Okay. Y cubed. Okay. Now, what gets left in my cubic root here? Oops, I gotta make sure my cubes do not look so weird. 3 cubic root. What do we get left? We got a 2, correct? And then what else do we have? Y squared. Are you seeing where these are coming from? All right, let's see if we can do the last one very quickly. And then we're going to do a couple quick examples, and we're moving on with multiplication after just a couple examples. All right, 4th root. When we're looking at the 4th root, guys, think about what we're trying to do here. We got 2 times 2 times 2 times 2 times 2. 4th root, are we going to touch the a to the 4th at all? Nope, because it is already to the power. How about b to the 9th? How could I rewrite that? B to the 8th times b to the what? First. How about c to the 10th? So c to the 8th, c squared. You guys see where I'm getting those values? Am I using that just multiplication property of exponents, where I can add exponents to get it? So I'm just splitting it backwards. Okay, so guys, I'm looking for groups of 4. Did I get a group of 4 here? Yep, so I got a 2. How about a to the 4th? Should come out what? A, right. How about, because that counts, how about b to the 8th? Does that one also come out?
B squared.
Nope. Oh yeah, b squared. Why did I say no? Yes, b squared. Yes, totally b squared. All right, we leave the b to the 1st. How about c to the 8th? C squared. Okay, and then we get our 4th root here. What goes underneath? 2b squared. Okay. Now, is there anything I need to fix here? Perfect. All right, loving it. All right, guys, are you feeling okay with this?
Oh.
Any better? A little bit? Okay, so here's what we're going to do. We're going to go straight to hard. We're going to do C and D. We're going to use C and D as our 2 examples. All right, when we multiply together, guys, we got to be focused. Focus and come in this direction. When we multiply together, understood there's a 1 out front. What 2 multiply together? 1 and 3, so that's going to be what? 3. And then we multiply underneath together. What's 8 times 40? That's 320. Awesome. Y to the 5th times y squared. Y to the 7th. So we have to bring it all together first. Now, you want to look at the values that we have to simplify. So we've got to look for the largest perfect square numbers that come out. All right, so we're going to go our 2 values. Again, if you want to use prime factorization, are you okay to do that? Okay. Now, guys, what is the largest value that comes out of 320? The largest perfect square number. That's not a perfect square number, but that was not a bad idea. What is it? 36. Goes 36 under 320. Go even bigger. It is not 120. 120 is too big, and it's not a perfect square number. Guys, what did I tell you to write on a note card?
Perfect squares.
Your perfect square numbers. Tell that many of you don't know them yet, so you don't even know what to try. If you want to go the fast method and not prime factorization, you need to know your perfect squares. Guys, it's 64. 64 times 5 is 320. All right? And when I have y to the 7th, I need it to be divisible by what number? 2. And the cool thing is with square roots, you only just have to take 1 out for it. So this would be y to the 6th. This would be y. Now we're getting pretty close to what we have. What do we get for this first one here? We get 3 times what? What's the square root of 64? 8 times what's the square root of y to the 6th?
Y squared. Y to the 3rd.
Y to the 3rd. Oh boy, what are we going to have to put in there? And then the square root of 5y stays there. So 3 times 8 is what? 24. And then we have to take the absolute value because it came out what? Odd exponent. The square root of 5y. All right? With me? All right, let's do the next one. Again, the numbers out front multiply together. 2 times 5 is just what? 10. And then I'm going to have the cubic root of our values multiplied underneath. 6 times 4 is 24. X to the 4th times x to the 5th is
X to the
9. Y squared times y to the 11th is what?
Y to the 13th.
Okay, so now let's kind of do our combo package that we know how to do in order to make this easier on ourselves. Okay, prime factorization of 24. Guys, that would be 2 times 2 times 2 times 3. All right. X to the 9th. How can I do this so I know that I'm taking the cube root of it? Is 9 divisible by 3? So can I leave that alone?
Yeah.
Okay, what can't I leave alone?
13.
The 13, right? I need that so it's divisible by 3. What's a number?
12. 12 is.
So we have y to the 12 times y to the what? First. Now can we take out our cubes? Yeah. So we have our 10. And it's going to be times 2. I can take out my other perfect cube, x to the 9, which gives us x what?
X cubed.
X cubed.
Yeah, X cubed.
Y to the 12 is a perfect cube.
So Y 4.
Yep, y to the 4. And then we get left here the cubic root of what's left in there.
3Y.
3y. Now we just have to simplify a little bit on the front. Would you guys agree? Yeah. And then 10 times 2 is 20 times x cubed, y to the 4th times the cubic root of 3y. All right, how are we feeling? A little bit better? Okay. All right, let's try now some other stuff you're supposed to be able to do. Again, you were all taught this last year from me, and you were taught it in Algebra 1. It says add or subtract if possible. Here's the rules you need to remember. You can only add and subtract things if they're like terms, right? Can you add 3x plus 2y more than what you see right there? No, because are they like terms? The same idea happens with radians or square root symbols or cubic roots. You cannot add them unless the number underneath are the same, which means many times you actually have to simplify before you can add and subtract. Once you do that, the radical doesn't move. It's just the numbers out front work with it. So here's what I mean. Are these already in simplest form? All right, so to add them, you just take the numbers out front. What's 2 and 3? Yeah, so 2 plus 3 is 5. So it's 5 times the square root is 7. You're done. That's it. Now, looking at the next one. I get 4 times the square root of xy plus 5 times the square root of xy. So you ask yourself the question, can I simplify my radical at all? No. So then you're like, are they alike radicals? So that means I can add, or if there was a subtraction symbol, you subtract just like normal, the two values, and you get 9 times the square root of xy. Okay, now let's look at the next one. I get 2 times the cubic root of x minus 2 times the cubic root of 5. Can I simplify either one more? No. Always ask yourself, can I simplify more? And the answer is no. So are they alike? No. These two are not the same, so I can't do anything. So guess what your answer would be? 2 times the cubic root of x minus 2 times the cubic root of 5. Absolutely what? Nothing. You cannot add them together because they do not have exactly the same radicand. That radicals have to be the same. So when we're working with it today, I think we actually might get through our notes. Let's see if we can do this real quick. Notice we asked you to make the natural jump between cubics, 4th roots, 5th roots, 6th roots, just because you know how to do square roots and the patterns. But let's do the first one together. I got 3 times the square root of 20 minus the square root of 45 plus 4 times the square root of 80. First of all, are these in simplest form?
No.
So if you do not simplify first, you can't go there. Are you guys with me on that?
Yeah.
So we're going to simplify our values next. So guys, let's simplify. All right, and I'm going to use fast method for square roots just because it's faster. All right, when I look at 20, what is the perfect square number, the greatest perfect square number that can factor out of 20? 2 is not a perfect square. 4 is a perfect square. All right, minus, now I'm going to do the same thing here for 45. What is the largest perfect square number that's a factor of 45? Yep, 9 and what? Remember, the perfect square number goes on the left. The number that gets left goes on the right. And then we go plus, the 4 stays there. And now we need to look for the largest perfect square number that comes out of 80. This is when, if you know your perfect square numbers, you start trying numbers below it. Does 64 go into 80? No, only perfect square numbers I'm trying. Does 64 go into 80? Does 49 go into 80? All right, does 36 go into 80? 25? 16? Times 5. All right, now we have to simplify each. Guys, what's the square root of 4? So we have 3 times 2, root 5. What's the square of 9? That made that one really nice. What's the square of 16? All right, now we're almost done. So we get 6 root 5 minus 3 root 5 plus 16 root 5. Oh, wait. Are we now all only adding and subtracting? Are they all the same radical? Yeah. So, and sometimes you only, maybe 2 of them are the same and you have to leave the third alone. That's okay. So what do we do? What's 6 minus 3? Plus 16. So it'd be 19 root 5. Does that make sense? It's a lot of writing, but you get it right. That's still a lot better than doing the prime factorization method. Would you? Do you see how big that problem would look across the page? Woo! All right, let's do another one of these. Okay. I'm not trying to give you the hardest ones out there, but guys, could we have to still be able to do this with our variables and all that type of thing? Yes. Okay. So let's look at this first one. Square root of 50. 25 times the square root of what? 2. So it's root 25 times root 2. All right. And then we're going to go plus, and we have our 3. All right. I heard it. What? 16. All right. Times the square root of 2. We go minus 5. And then what is the largest perfect square number that's a factor of 18? 9. Root 2. Okay, guys, what's the square root of 25?
5.
So we get 5 times the square root of 2. All right, 3 times what? What's the square of 16?
4.
4 times root 2. Well, minus 5, what's the square of 9? 3 root 2. Okay, so we get 5 root 2 plus 3 times 4, which is 12 root 2, minus 15 root 2. Now, I'm being really nice because can I combine all of these right now? Yeah. That's, again, sometimes you might not be able to combine anything, but you still have to simplify as much as you can. Okay, so always think simplify first and then combine. So what do we do here? 5 root 2 plus 12 root 2 is what? 17. Minus 15 root 2? Good job, guys. Are you guys feeling a little bit better with those? Okay. Notice the more we get used to just simplifying radicals, the faster it is. All right, yes, sir. Question? Yep. All right, let's do the next one. All of a sudden, it's what? Cubic root. Now, again, if you're really good with cubic root, perfect cubes, this isn't hard. If not, you're going to have to do the prime factorization for all of these. I'm going to use the perfect cubes because it's going to save us time. But when we do this, you approach it the same way as you did the other one. I have to sit there, the 5 stays put, but I'm going to have a cubic root of my perfect one, and I'm going to do the one that doesn't. Guys, what is a perfect cube that comes out of 16? 8, right? So we have an 8, and then notice the 2 stays because it's the one that's not the perfect cube. Does everyone agree with me? You can see where we got our 8 and 2. And you go minus 2. Now I'm going to do the cubic root when we work with this. And I think this was actually, oops, I forgot my cubic root symbol for my next one. Oops, bad teacher. Okay, guys, hello. A perfect cube that comes as a factor of 24. 8. At least that's nice. Okay, now we're going to do our simplifying. All right, what's the 5 times the cubic root of 8? What's the cubic root of 8? 2. And we got times the cubic root of 2. Minus we got 2. What's the cubic root of 8 again? You guys told me it was what? 2 times the cubic root of 3. Guys, what's 5 times 2? 10 times the cubic root of 2. Minus what's 2 times 2? Times the cubic root of 3. Can I combine these? No. So are we in simplest form? Sometimes you just can't combine them, but even after you simplify. All right, how are you guys feeling about those? All right, now the next one, this is where it probably is going to take you a little more time. Like we just skipped. We went from cubes to where? Woo! 4 groups. We just went there. But do the rules change? Not really, right? So is this the time that you need to do prime factorization? You do prime factorization. If you understand what perfect roots, fourth roots are. Great. But how do you guys want to do this one? Do the prime factorization? You know what, people? I'm good with prime factorization on this one. Okay, so let's do this one. We got 10 to the fourth root. All right, if we do prime factorization, can anyone guess probably what lovely numbers that we are working with? Think about it. You have to go over here into your tree. You got 162. You got 2 and 81, right? Right? And what do we get here? 9 and 9. 3 and 3. 3 and 3. And this had to go all the way down here to what? 2? Okay. So my prime factorization is basically 2 times 3 times 3 times 3 times what? 3. Okay. Plus we got the fourth root of 32, which, all right, you have to do the prime factorization for that one as well. You got 2 and 16, 2 and 8. Okay, sorry if I just skip, but do we know that's 2, 2, and 2? Would you guys agree with me on that? Did I get all my 2's the right way? 2 and 8, 2, 2, 2, 2, 2, 2. Gotta make sure my math goes together. Yep. Okay, so we get 2 times 2 times 2 times 2 times 2. All right, let's simplify. Do I have any fourth? Yes, 3. So we got 10 times 3 times the fourth root of 2. Any over here? Yes, we have one set of 4, so the 2 comes out. So 2 times the fourth root of 2. Well, that's 30 times the fourth root of 2 plus 2 times the fourth root of 2. What's 30 plus 2? 32. Because these are the same, are we allowed to combine them this time? Yeah. So we get 32 times the fourth root of 2. All right, how are we feeling? All right, when we say this, and you guys have been telling me I feel good about stuff, is when I've been seeing not so good type of scenarios in this class when it came to like quizzes and tests. So we have a little bit of time. I want to go back and let's fill in the gaps for where we skipped to make sure that we got through, okay? Let's do a couple of these together. Let's go back to the multiplying and simplifying, which is what you were supposed to learn yesterday on the quizzes, which for some of you was very easy for you. You remembered, some of you did not. But let's just finish this together until the bell rings. Okay, friends, how do I multiply? Numbers out front go together, correct? Okay, so 3 times 2 is, all right, and then we multiply the numbers underneath. So 7 times 21 is 100 and what? 147, and then we multiply our variables together. X cubed times x cubed is x to the 6th. And what do we have? Our y squared just come along, correct? Now that they're multiplied, then you have to simplify. And that's when we're doing square roots, so we're going to have our 2 square root symbols. Guys, what is the number that can come out of largest perfect square number that is a factor of 147? 44, 40, 49. How did I know this, guys? What's a factor of 21? 7. 7 times 7 is 49. Is one way of thinking about that, so 49 times 3. How about x to the 6th? Can I pull it out? Yeah, because it is a perfect square. How about y squared? All right, now we can simplify a little bit more. We got 6 times, what's the square root of 49? Square root of x to the 6.
X cubed.
All right, square root of y squared.
Y.
Root 3. So 6 times 7 is what? 42. Now what do I have to have? Ask my values of both of those because they're odd exponents. We get the square root of 3. Kind of messy, but not impossible. Now let's do this with a little bit messier. Let's do it with the cubic root.
Oh, can you go back for a second?
Oh, so sorry. Yeah. Now, this is where Mrs. G comes back from your past and go, guys, remember, you really need to remember how to do this. This will come back to haunt you if you don't. This was that moment. This is why last year, myself and Mr. Cheney were so insistent you learn how to do square roots. And we reviewed it a lot starting first semester. It's because without really teaching you much, we're expecting you to go to the next level with different root values than just square. So let's look at this next one. Do I have any numbers out front that I have to multiply together that aren't understood to be 1 and 1? Okay, so let's multiply them together first. 25 times 5. X times x to the 4th. X to the 5th. Y to the 8th times y cubed is y to the what? Okay, so let's see if we can use this to our advantage. And I'm going to do non-prime factorization method on this, or combo package of it. Guys, guess what 125 is? It's a perfect, not square, perfect cube. So we got 125. Oh wait, I have an x to the 5th. What do I need the value to be divisible by, the exponent? 3. So what could I take away from x to the 5th to get it so it's divisible to an exponent 3? So yeah, I'm going to take an x squared out, which leaves me an x what? Cubed. Now, y to the 11th. I really want that to be a y to what power? 9, which means I had to take out what?
Cube.
9 plus 3 would be 12. Divisible. So we have our squared. Now, here's the cool part. Do I have to do anything with this one over here? No, because there's no cubic roots of any of those. But now we just have to get our values below. What's this cubic root of 125? What's the cubic root of x cubed? Cubic root of y to the 9th. Y what? Cubed. Yep. So we get the cubic root of x squared, y squared. Okay, now, this is putting last Friday's and our quizzes yesterday and what we're doing today together, all together. How are we feeling now? Are we feeling any better with cubic roots or fourth roots or fifth roots? Are we feeling a little bit better with this? Now, here's the thing that needs to improve. I need you guys not to put stuff away for just a moment, okay? I've been grading your homeworks. I've been not happy with homeworks. Number 1, I have to see work. Just giving me an answer, I'm going to assume the worst, that you're cheating and writing down the answer key. Are you with me on this? I will never give credit for that. It's a completion grade. So do you have to attempt every problem? Yes. Gregors, what if I don't know what I'm doing? You might know more than you think if you actually try. Here's the other thing. You're given answer keys for certain problems. The whole point behind that is, I'm still talking. Doesn't that mean that you can use that to work the problems that aren't on there? But you have to correct it with a different colored ink and turn that in and let me know. If you got it all right, -0 is great. But it's a -0 for those problems, not the whole thing. All right? If you don't do that, and by the way, I've been asking you that for the last 4 weeks. And it says on the answer, the assignment, to do the same thing. So do I expect it from you? Okay, that's the reason why a lot of you are getting 8 out of 10 or more taken off, because you're not following what's a completion process. So have a phenomenal day. Head yourselves on over to chapel. And good job today, guys.